Hello everybody. I thought I would do another example that shows you how to do the problems when we have a different axis of rotation and it's not the x or y axis. So I am looking in 6.2 where we're actually talking about which method we liked better, cylinders or cylindrical shells or washers and discs. And this one can actually be done either way. I did it with cylinders, and you'll understand why in just a second. I'll kind of explain it. I'm trying to find the example number. It's, let's see, on page 19. So it's example 3, letter C. All right, so let's go ahead and start here. I don't have a lot. I'm going to go about the line y equals 1. So let's draw this thing out just a little bit. I'm going to put all 4 quadrants on here. If I'm looking at the line y equals 1, I'm kind of right up here. I should always draw that out a second. Let's see if I can move it to the right place. Either that or I'm moving my 1. All right, so this dotted line that I'm going to pop up here, that's going to be y equal to 1. And that's what I'm rotating around. I know that because this is right here. Okay, so I have x equals y minus 3 squared, and I have x equals 4. So let's look for points of intersection there so that we can get a couple dots on this. I'm going to set them equal to each other. I'm going to say 4 is equal to my y minus 3 squared. I can square root both sides, so let's do that. That's actually probably the easiest way to do this one. So if I square root both sides like this, I'm going to get a plus 2 is equal to a y minus 3. I'm going to get a minus 2 is equal to y minus 3. So remember, you got to get both of them. Okay, so I got to look at both. If you want to square that and then move the 4 over, you can and refactor. If I solve though, I'm going to get a 5 equal to y, kind of shortcutted it, and here I'm going to get a 1 for my y. All right, so I get y equals 1 and y equals 5. If I look at 7 those back in to find my x's, I got to use the first equation. So I'm going to say at y equals 5, x is equal to, well, it better be 4 because that's what we set it equal to. I don't know why I'm doing this again. You can check yourself there if you want to. So I set it equal to 4 right here because the x equal to 4. I'm not sure what my brain's doing here. So let's go ahead. I have an x equal to 4. So I have a 0.45. And I have a second point that's 4, 1. All right, so let's make our x-axis 1, 2, 3, and 4. We'll make a fifth one and make this x. Okay, so I have a point at 4, 1, so I have one that's right here on the axis, right? I have a second one that's at 2, 3, 4, and 5. This is 5 gone up on the y. So then it's at 4, 5, so I have a second point that's right up here. Let's draw on that y equals 4 now that we've got it. I'm going to draw it in blue just so that you can see it. There we go. And the points are almost right on top of it. There we go. Really, they are. All right, well, that didn't help us a ton, but if I look at that, x equals y minus 3 squared, that's going to be a quadratic. So it's going to be a sideways parabola. All right, if you want to figure out which way it goes and where it looks like it's going, take a look. We can say at, let's say y equal to, pick something in between the two. We have 1 and 5, so let's pick 3. Then we know that x is equal to 3 minus 3 squared, and that's just equal to 0. So we have a point at 0, 3 for that quadratic. Right, so I have a point right here. That's actually my vertex there. So I have something that looks like, whoa, this a little shaky there on the one side. So this is what I'm rotating. So let me color it in for us. I'm rotating this, and I'm rotating it around that x equals 1 line. Okay, so I'm rotating right around this way, or the other way around, I guess. So let's draw its mirror image. Now what I'm going to do is I'm going to count as far off as I was. So right here I have another point right where I was at. And then I have a second point that's 1, 2, 3, 4 up from there because it was at 5. So I'm going to make, this would be 1, 2, 3, 4 in the other direction. So let me count. I have 1, 2, 3, and 4. So I'm going to go down to here. I'm going to have the same thing where I have 2 over from that right about here. I'm going to have my little vertex. Again, count up from here, 1, 2. I'm counting up from here, or down from here, 1, 2. So I know that was my mirror of my vertex. I'm going to have something that I totally missed the point on. Let me turn my thing sideways. I missed again. Hold on. I'll get there. Let's do half. It goes like this and like this. There we go. Now I have my parabola. Okay, so I rotated it around. All right. Now, here's the thing. If I wanted to do discs, I would be cutting through this thing like this, right? The hard part there is that I would have a thickness, a dx thickness there, right? That means I would need to find this thing in terms of x, and that's really kind of ugly. So I'm not going to do that. I'm going to take the easier route and erase that. I'm going to use cylinders, all right? Because I can leave that x equals y minus 3 squared equation alone. So let's draw a cylinder here, and one right about here. And draw my cylinder. There's my cylinder, right? So if I draw it, I have, let's pull it out. There's my cylinder. Again, you can see here, I have a thickness, it's a dy, exactly what I'd expect. So I've got everything in terms of y, that's what I want. Let's take a look at the radius. So this is the different thing. So the radius I'm looking for is from here to here. It's from 1 to wherever that curve is, right? So if I look at, let's say, my lowest point there, right here, I know I have a radius of 0. So instead of it being at y, which is normally what I do, I normally say my radius is at y, it's at, so like this whole thing is equal to y, right? But this part of it's just equal to 1 if I zoom in. This part's equal to 1. So what I have left for my radius is equal to y minus 1. Okay? Makes sense? So I made it smaller, so that makes now this point right here equal to a radius of 0. That's exactly what I want. All right, let's take a look at our height. Our height is just going to be from here to here, okay? So I'm going to go bigger, my rightmost minus my leftmost. So I'm going to start here with this line. This is x equals 4, so I'm going to say 4 minus, this curve right here is my y minus 3 squared. Right? So if I clean that up a little bit, I'm going to get 4 minus, I'm going to FOIL this, y squared minus a 6y plus a 9. Let's clean it up even more. That's going to be equal to a 4 minus a y squared plus a 6y minus a 9. So I'm going to get a negative y squared plus a 6y minus a 5 is my height. Right? So let's spread out this little cylinder. We're going to cut it open, just like we took it off the water bottle. This right here is, oh, wow, bracket didn't work at all. This right here is my height. Okay, that was the height of the cylinder. The circumference there is going to be c equal to 2 pi r. My r this time is y minus 1, so I'm going to get 2 pi times y minus 1. All right, we are almost there. We have right here, we have our one dimension and we have our second dimension right here. So I can multiply those, my height times my width or length or whatever you want to call the second one. So I'm going to say my area, again in terms of y, is going to be 2 pi times a y minus 1 times my negative y squared plus a 6y minus a 5. This is kind of a foil on steroids here. So I'm going to distribute, and I'm going to distribute the first term. So a of y is going to be equal to 2 pi, there's the easy part, times a negative y cubed, I'm doing this term first, plus a 6y squared minus a 5y. And now for the negative 1, negative plus a y squared minus a 6y plus a 5. All right, let's get like things together. I'm going to have my a of y is equal to 2 pi times, I only have 1 cubed, so a negative y cubed. Let's see, I have this square and this square, so plus a 7y squared. Yep, I got that here. Let's see, I have this y and this y that's not squared, minus 11y plus my 5. All right, marvelous. From here, I'm going to go down to the next page because we have room. I'm going to say that my, just a little over, volume is equal to my integral from c to d of a of y dy. That's going to be equal to my integral. We'll put those limits on there in a second. I'll pull the 2 pi out front times my negative y cubed plus 7y squared minus 11y plus 5 dy. We're in danger of a cat helping me here in a minute. All right, so let's take a look at our y values. Again, I'm just going to use, you can either look at, these y values right here. You can go up to your graph and you can say, gee, I go from 1 all the way up to 5. Okay, so we can see we go from 1 right here all the way up to 5. So we're just looking at that one side. I'm going to put on those on 1 to 5, and now I need to just integrate. What you should find there, if I got a warning that my iPad's going to die soon, you should get a volume that's equal to 2 pi. I'll do the first part of the integral for us, times a negative y to the 4th over 4, plus a 7y cubed over 3, minus an 11y squared over 2, plus a 5y over nothing. I'm going to evaluate from 1 to 5. So this one gets a little messy when you sub it in. I'm going to let you go ahead and sub those in. What you should come out of there with is a 128 pi over a 3. Okay, so that's going to be my answer there on that one. I hope that helps as far as like seeing how that axis shift works. You know, this is like really zoomed out, you can't even see it now. So it kind of helps to see how that axis shift works. So I hope that's helpful. I figured I would put one up that had an axis shift in it just so we can see it. Let me know if you have any questions, and I'll see you soon. Bye-bye.